Welcome back, students. We're still in integration by substitution. Well, you remember how difficult it was to adjust the chain rule when we are doing the differential calculus. The counterpart for the chain rule is the integration by substitution in anti-differentiation, so it's no wonder it's complicated. Let's go over to the next set of problem, 3.3, and we may end up with a kind of problem that are even worse. Let's see, how do you handle this problem? For this problem, let me start with an auxiliary problem or kind of reference problem like this. Instead of x to the third power, let's change it into just x. Is this problem doable? In this case, it's going to be doable. Typical insight and differential computation will apply here, because if you take your character, say u as 1 plus x squared, the derivative is 2x, and consequently what do you get? dx is equal to 1 over 2x du, and we can plug these into the original integration, and then we can simplify. Let's do it. Plug everything in, and then this is u, and then dx is equal to 1 over 2x times du, and do you see the simplification? X and x cancel each other out. What do you get? 1/2 integral of square root of u du, or if you prefer, u to the 1/2 power. I hope everybody can clearly see 1/2 power is equivalent to square root of u, so let's go back there. And then let's finish this computation. 1/2 was there before, and you have to increase the power by 1, and then divide. So this is 1/3, and then what was inside? And that's a full computation of this problem. Not the same problem, but this was standard. Now let's go to this problem. And why did I talk about this reference problem? Because they are related. It's quite obvious what to take as an inside function and what to work with for the differential part. It's the same thing all over again. Now, if you do this, you're gonna get u here, and then same 1 over 2x du here, and you're gonna get appropriate simplification. There's a bit of a problem though. And x cubed and this x cancel out, so we have x squared left, and the resulting integral here is not a u integral. I still have x squared left behind, and I have to work out the next question here, how to remove it, because without this x squared somehow removed or re-expressed in terms of u, I can't do this. How do I handle this problem? Well, let's go back to the original substitution. U equals to 1 plus x squared, isn't it? From here, you get x squared is equals to u minus 1. From here, You see, u equals to 1 plus x squared. From there, I get x squared equals to u minus 1. And let's emphasize this in different color. In green. So this whole thing will become let's use green here, and let's use green here. Finally, we successfully rewrote this as a u integral. Let's move it up there. Okay, I now regret using the square root over here, because obviously 1/2 power is a lot easier to deal with in this case. Well, I didn't do it earlier, so I have to do it now. So u to the 1/2 power there, and let's work out this problem. Distribute, and then you're gonna get u to the 3/2 power, and then 1/2 power like this. And we have a sum of two power functions, right? So we have antiderivative like this, u to the add 1 to the power 5/2, instead divide, add 1 to the power, divide, like this. Oh well, we're almost done here. As a matter of fact, why am I putting plus c over here? This is the antiderivative computation. It's all done, and antiderivative arbitrary comes here. Okay, all right. Let's finish this. I can distribute and simplify, but more importantly, I have to recall what u was. What is u? It's 1 plus x squared. So this is 1/5 5/2 power, but from 1 plus x squared. And then minus 1/3 3/2 power. And I need 1 plus x squared here. Okay, there goes the full computation of the problem. This would have an easier problem, but unfortunately our problem is heck of a lot longer. We take substitution, derivative computation, and differential and put everything in. Great, but then again, our problem is just beginning. Our trouble is just beginning. This x squared is not going away. So what do? Let's go back to the original substitution and then solve for x squared and then put those u expressions back in. And now we have a u integrals to work out, but this is far more complicated u integral. You have to break up the parentheses, get the power functions, and then work out the power rule. A little bit more complicated. And then be careful, the problem is long, so that maybe you can get exhausted and then just stop halfway through, or even worse, stop at 90%, and that can be rather frustrating. Anyway, here's the solution. Better solution is inside this arrow mark, so here we go. There's a full solution there. Do we have enough time for another problem like this? Maybe not, so let me save some time. Let's work out this problem, And then the idea is pretty much the same as well. This x cubed will turn out to be x squared times x. You see? Inside is y, and then the derivative, and then differential computation. Put everything in, and as before, I have this residual x squared. Similar kind of problem, similar kind of computation as before. Now I'm about to open the cell and then show you the full solution, but before that, please try to remember what we did before. From here, y equals 1 plus x squared, we solved for x squared and then got x squared is equals to y minus 1. We got this one right from here, and that's gonna come here, and the resulting integral will be y integral. Here we go. We get y minus 1 over 2 square root of y. And how do we handle this anti-differentiation? We have to break up the numerator, or you can bring up this denominator upstairs by taking a negative power. Looks like I took the second method here. Break up the parentheses, apply the power rule, one term at a time, and then finally substitute everything back in. And that's how we do it. Let me keep the entire solution in a single viewing window so that you can look at it. And I'm stopping this lesson video here.